Hello everybody, my name is Dominic and I'm going to record a couple of videos explaining the usage of the wolfram language. The wolfram language is sometimes referred to as a symbolic language or a computational language. We will dive into the specific details soon, but you can think of this language as a powerful tool focused on solving math problems. My main usage with this language was to learn math, especially calculus and linear algebra, and as a complementary to using Python's SymPy module, allowing me to perform analytic calculations with a simple syntax. After using this language for a while, I found it having a lot of interesting features, some of them allowing the usage of very complex machine learning algorithms as built-in functions like classification and image style transfer, etc., making it a very versatile tool for the modern programmer. This language was developed by Stefan Wolfram. You can look up his Wikipedia page to get to know about his work. I learned about him after doing some work on cellular automata and finding his book New Kind of Science. This is a very interesting book, one of Stefan's amazing work, dealing with finding a new approach for explaining highly complex phenomena with simple programs. Anyway, Stefan Wolfram also developed the Wolfram script that is mainly used as the language supporting the Mathematica tool for technical computing. This series, I will be focusing in learning the Wolfram language without the Mathematica tool. I will leave a link in the description to a nice article I found showing how to run the Wolfram language locally from a Jupyter notebook. And this video, I will be focusing on using this language for basic arithmetic, showing some basic syntax and functions. So before I start, please consider leaving this video a like and subscribing to my channel. This helps me a lot, so thanks in advance and let's start. So the Wolfram language has quite an overwhelming documentation center. You can find out practically everything you need just from the website. But as I said, this language has a lot of features and a lot of functions, so you might get lost, but don't hesitate to try yourself. Everything is explained quite clearly. So we will start with basic arithmetic and the basic operators like addition. Running the Wolfram language in the Jupyter notebook can be quite easy. Pressing Shift Enter will give us a result of this expression, and putting a semicolon after an expression, if I will run it, I will not get an output, but this still will return value that I can save into a variable, and in this way I can get this expression evaluated and assigned to this variable. And if I would like to print out this variable's value, I can use the print function like this. And in the Wolfram language, functions are using square brackets. Okay, so I can put the variable x inside the square brackets of the function print, and if I will run this, I will get the result printed. Okay, so this is the basic addition operator. We can use also subtraction and also multiplication and also division. Okay, so this is what we get. Notice that if I will run this expression like this, we are going to get a different representation. Okay, so instead of using the operators, we can use the functions. Every arithmetic operation has a corresponding function. Plus is the function resulting in addition of those two values. We can use plus function on lists. This is the way we are creating a list in the Wolfram language. And in this expression, we are sending the plus function to lists, and what we are going to receive is an element-wise addition, meaning the first elements will be added and then the second elements will be added, and we are going to receive a list containing all the added values. So here we have subtraction, we already saw it, and the corresponding subtract function will give us the same result. Times is the corresponding multiplication function, giving us this result. And we can use also the operator, and we can also use this operator as we saw. But notice that we can also use an empty space between two values, and it will result in multiplication. Here we are seeing division, we already saw it. The result we are receiving here is still in its fraction form, and also if I will run the divide function, we will have this result, and using this function will give us the numerical approximation of this value, and this is what we are used to receive when we are using languages like Python or C. The n function can receive a second parameter. With this parameter, we can define the precision of this numerical approximation. And like this, we are telling the n function to give us a numerical approximation with 20 digits. This is the operator we use when we want to calculate power. So 3 to the power of 2, we can write like this, or we can use the power function. And we can also use this function to find the square root. And if we want to receive real values, we will have to add this dot afterwards, and we will get it in a real form. And notice that running the square root function on a negative real value will result in a complex value having a real part and an imaginary part. Mod is the modulo function, giving us the modulo of 5 on 3, as resulting in 2. Log will give us the base e logarithm, and the exp will give us the exponential. From here on, you can see that the Wolfram language has a lot of built-in functions that when you use a language like Python, most of the time you will need to import some kind of a module. But here, those functions are built-in and accessible straight out of the box. You can see in this example that I will get the factorial of 5 with this function, and I can get the same result if I will just use the number and this symbol after it will give us the same answer. We will get into lists and collections later in the series, but we saw that this is a list. So if I want the total of the elements, I mean summing all the elements together of a list, we can use the total function, and this will give us this result. We also can have a mean of this list. I will show first without the n function. So this will give us this result, and using again the n function will give us a numerical approximation. Accumulate will give us totals of elements. I will run this function on symbols so we can understand what this returns. So we will have a and a plus b and a plus b plus c and a plus b plus c plus d. Okay, so this will result also in a list. If I will run this function on number, we will just receive the accumulated totals. If we want the successive differences of elements, we can use the differences function, and this will result in this value, and we can run this on numbers so we can see the results. So here we can see the difference is 1, and here we can see that the difference is 4, and here is the difference is 2, and here is the difference is 1. And something similar we can find with the ratios. This will give us the ratios. Yes, I will not go into this too much, but this is the result. So I will continue with numerical functions, and you can go to this link to see where I found and learned this stuff myself. So we have the round function that will round this real value and will give us an integer value. If we want the value to be floored down to, let's say, 4, we can use the floor function, and using ceiling will give us the closest integer larger than 2. We have integer part that will give us just the integer part from a value, and if we want just the fractional part, we can use fractional part. We have minimum and maximum. If we provide it a list, it will give us the minimum value or the maximum value. This function will give us the absolute value. And if we want to check and get the sign of any value, we can use the sign function. Clip is a very interesting function. If we will give it a value between -1 and 1, it will give us the same value back. But if I will give it, let's say, 6, it will just give me 1, or if I will give it -6, it will give me -1, clipping the values between -1 and 1. If I want to change the range of the clip function, I can provide this range in a second parameter to this function, and in this example, the clip function will get a value of 8, and it will clip it to the range of -4 and 7, so we will get 7 in this way. Also, if I'll give it a larger number, we are going to get 7 because it is clipping it, but if I will give it something like -7, it will give us -4 because this is the lower range. Rescale will give us normalization of the values in this list, basically equivalent to this calculation. If I will run it, we will see that this is what we are receiving. Chop is a function that will replace values that are close to 0 with 0. And if I want to provide myself the definition of close to 0, we can do it with the second parameter. So in this case, we will receive a new list. And in this new list, we will just have this value from the older list, but this value and this value are smaller than my definition of close to 0, so it will zero them out. Now we will see a couple of integer functions, and this is the link that you can find about them and more. The binomial function will give us n choose k. We have the Fibonacci function, so the fourth Fibonacci number is going to be 3. And if I want the third harmonic number, we can find it here. You can learn about harmonic numbers in the Wikipedia. So lastly, we are going to see some number digit functions. In this function, integer digit, we can provide this function an integer, and it will result in a list containing all the digits from the value we provided it. We can perform the reverse of this process with from digits, meaning I can send this a list of integers and it will bring me back this result. I can check the length of this integer with integer length like this, and it will give me 6. Digit count is quite an abstract function. You can read about it more in the documentation, but let's say if I will give it the value 9 without any other parameters, we will get a series of values showing us 1 in the 9th place. If I will give it 8, it will move to the 8th place. If I will give it 1, it will give us 1 in the 1st place. With number digit, we can provide it 2 parameters. The first one is a number, and the second one is the index of the digit that we want to be returned. Let's say if I want this 3, then we can provide it with this value 1, because it starts to count from here. Let's say this is the place that we have this decimal point, and this is the 0 location, and this is the first place. So this is how we will get this 3. If I will give it here a 0, we will get the 4, and if I will give it the 4, we will get 2, because it's this number. Integer reverse is a function that if I'll provide it an integer, it will just reverse the order of the digits and will give us this value. And here I'm going to show 2 functions. Integer string will cast this integer value into a string. I can show this by running the head function. The head function is pretty much similar in this case to the type function in Python, giving us the type of the value. So in this case, we will get an integer, but if I will roll back and run it on the result of integer string, we will see that we are receiving a string value after this function runs. With the base form function, I can print this value, the first parameter, in the base that we provide in the second parameter. In this case, this is in base 2, so this is 12 written in base 2. If I will do it in base 8, we will have this number, and if I will do it in base 16, we will see that we use characters also. The integer name function is very interesting, that can translate this number. So every number we will give it can be described in common English language. And we can also use Roman numeral if we want to translate this value into a Roman numeral. Yes, like this. And for last but not least, the number decompose. It will receive a number and a list of coefficients that it will use to reconstruct this number, and will give us this result. Like for constructing this value, we can use 2 times this part, 0 times this, 3 times this, 0 times 5, 2 times 2, and 0.65. And this is the decomposition of this value. So I hope you enjoyed this video. I will continue in the next video with the topic of Boolean algebra. If you like this video and my content, please consider subscribing and giving me a like, and I will see you in the next time. Goodbye.